everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Daniel Svoboda. We also have Ben Wilson.
Hello, hello.
I'm Charles Max Wood from devchat.tv. And yeah, it's just the three of us this week. Daniel, you haven't been on for a while. Do you want to just remind people who you are and what you do, and then we'll dive into our topic here?
Sure. I specialize in natural language processing. I've done various careers right now in telecommunications, finance. I work with Verizon, AT&T, Bank of America, Standard & Poor's. I actually just now received a position at Moody's, and this week was my actual start date. I hadn't... Like everyone else, I'm working remote, so I still have to wait for my laptop, and I've been starting meetings. But my plan is to specialize in natural language processing for financial applications. So I've been making my career more goal-oriented towards that specific area, like reading economics books, seeing what type of natural language processing applications are done in that area. And I've been working on a nifty new website about myself, which should be coming out next week, hopefully.
Cool. Well, it's good to catch up.
I remember working my tail off to become a senior developer. I read every book I could get my hands on. I went to any conference I could and watched the videos about the things that I thought I needed to learn. And eventually, I got that senior developer job. And then I realized that the rest of my career looked just like where I was now. I mean, where was the rush I got from learning? What was I supposed to do to keep growing? And then I found it. I got the chance to mentor some developers. I started a podcast and helped many more developers. I did screencasts and helped even more developers. I kind of became a dev hero. And now I want to help you become one too. And if you're looking forward to something more than doing the same thing at a different job 3 years from now, then join the Dev Heroes Accelerator. I'll walk you through the process of building and growing a following and finding people that you can uniquely help as you build the next stage of your career. You can learn more at devheroesaccelerator.com.
So this week we're going to be talking. So yesterday we were supposed to record an episode, and I was sick, and so we didn't record. And we were talking. Ben and I were talking, and he mentioned that at DataBricks they've been mentoring new folks to help them kind of come up to speed on how they can do machine learning and help their clients with machine learning. And I thought that was really interesting because he said that you can kind of explain this better than I can, Ben, I think. But the context was essentially that there were differences in the way that you all approached your mentorship. And I'm curious just to know how all of that is going and what you told people and how that differs from kind of the way that other people learn machine learning or level up in machine learning.
Yeah. To set the stage, the people that are coming in are extremely experienced data engineers and software developers. So these are people that are advanced in their careers. Some of them have been working at DataBricks for a while in the field, and a lot of what our clients do, predominantly with Apache Spark, is data engineering tasks. All of us have to know how to do that and deliver architectures and sometimes solutions for customers. But more and more customers are expressing greater interest in not just doing fun little projects in ML, like, we built a POC and it predicts this amazing thing. Now, people are now saying we need to actually put something in production and get serious about this. So it has this dearth of knowledge for a lot of people because most people are exposed to what it looks like when you're trying to search online. Like, hey, how do I get started in ML? It's all algorithm focused. It's all building toy use cases on super clean open source data. You can download it even from Kaggle, and you can see just how clean that data is and how easy it is to get started with just throwing algorithms at it. But that's not what customers struggle with. So our process of how we're doing this internally to enable our people to help other people do this right is through mentorship by doing capstone projects. And it's how I've done mentoring in the past with people at previous companies, where you do the entire process soup to nuts. That doesn't mean you get this clean data set delivered to you that has immaculate labels associated with what each feature is and a simplistic data set. It's more of, we're going to go through discovery phase. We're going to find a problem that seems relevant to solve. Go find the data for that. And in the process of finding that, what we were talking about yesterday, Chuck, was what the message that I'm providing to my mentees is when you're dealing with a real world use case. And this also follows on from what in your intro, Daniel, where you're like, hey, I'm learning finance books. I'm learning about like what people are doing in this space. That's kind of how you do data science work and ML in the field. So one of the use cases that one of my mentees has is incredibly fascinating, very useful use case for an actual customer that she has. And it's about equipment survivability. This customer and this company provides these machines for end use consumers to use. And these electronic components, they are usually in somebody's home for a very long period of time, sometimes years. And they collect data about that. So every 15 minutes or so, there's a data dump that happens from this hardware that gives a lot of information. Stuff like how much current is the chip consuming and what is the voltage from these components and any other electronic data that's coming from the raw components on there. So you just get this as this massive data dump from every piece of equipment globally that's been shipped out. These things fail. When they fail, it really pisses customers off because now they can't use this anymore. And they really like using that every day. So the intention for the company is to streamline the process of detecting when one of these is going to fail imminently and then sending out replacement equipment 2 weeks before it's going to fail and just say, hey, customer, we're really sorry. Here's a new piece of equipment. Can you please just put the old one in this box and we'll pay for the shipping back and we'll help you set it up and everything. And that's a fascinating use case for ML. It has massive impact for that company in building good trust with the customer. So my direction to my mentee is, hey, in the initial phases, don't think about algorithms. Doesn't matter what model you're going to use. We'll get to that eventually and we'll test out a bunch of stuff. But the first stage is understanding the data. And that doesn't just mean EDA. It doesn't mean, hey, plot a bunch of correlations and figure out what these signals mean to one another and which one kind of, has a correlation to a failure. That is important. But the first stage is understand the hardware itself. What are these actual signals? And this applies across all of ML and data science work. And it's something that I don't see a lot of people do until they're far more senior in their career, which is, hey, a lot of our work that we're doing, a lot of people say, yeah, most of data science work is feature engineering and data manipulation. That is true. But what informs how you do feature manipulation and feature engineering work is fully understanding the process that you're dealing with. So I asked her, hey, talk to hardware manufacturers or talk to the hardware engineers, the design people who build these pieces of equipment. Ask, what is this actual signal? Can you show me on a schematic what this is? Can you explain to me how this transformer works? This digital to analog converter, what is going on here? And then go read the technical manuals, the papers that have been written about these systems. Because the deeper that you get an understanding of what these signals are, it starts to formulate in some sort of subconscious level in people's minds once they really grok what is going on with the problem space that they're dealing with, that they'll be able to have these creative insights about how to manipulate the data in a way that makes it more useful for correlation detection. So you end up building a better model. You end up being able to explain your model better to the business because you're now able to communicate in their language because you know the problem space that's going on. And it allows you to detect things that just don't make sense. So that's a really long answer to your question, but that's kind of how I've been explaining to people, like, hey, this is really how you need to think about ML problems and ignore the algorithms at the beginning.
Yeah, it's funny the way that you kind of go into this because like the deeper I get into just software in general, this is the same kind of discussion that you have with people, right? Is that you need to understand the use case. You need to understand what everything means. You need to understand the problem is being solved, the things that are being measured, the things that are coming, that you're going to be working with, the kinds of data that you're going to be dealing with. And at the end of the day, if you don't, my experience has been that those things generally don't get communicated clearly. They kind of, people have the curse of knowledge and they just kind of work with, well, we just assume that you know what we know. And so then when I wind up building something, right? And there's usually some kind of analog or some kind of correlation between what I'm building and like the real world, right? Whether it's monetary or location or something like that. But if I don't understand the parts of it that they care about, then at the end of the day, I'm probably going to leave something out that's important. And then they have to come back and say, oh, no, we needed this. Oh, no, we needed this other thing. And so, yeah, I mean, what you're talking about isn't unique to machine learning, but at the same time, it's something that I don't know that you can pick up without actually doing the process that you're talking about and saying, okay, what is this? What does it mean? Why is it important? How is it used? You either pick it up that way or you pick it up by making mistakes over and over again, hopefully different mistakes each time, right? And having somebody say, no, actually, this matters because this.
Mm-hmm. Yeah. And I see a lot of data science practitioners that are insulated in a team. They're walled off, siloed away at companies. They're just sometimes physically walled off from the rest of the organization, where it's like, hey, data science team is working on this crazy thing. We don't know what they're doing, but they're really smart. They'll figure it out. And then you're really scrabbling around in the dark if you're just looking at the data. You can look at patterns in data and look at correlations and come to the wrong conclusion. So the same as like front-end web development or app development, you can look at requirements on a piece of paper and say, oh yeah, I think I understand what they want here. And if you don't ask them or show them or just interview them and really get to that, why do you want this built? Yeah, you could build something that's completely not what they're looking for, or something that just does not function correctly.
Yep. Daniel, I'm curious how this translates to what you've done and what you've seen.
Actually, it does, because Ben was mentioning that data scientists now have to be like data engineers. And that actually is very, very true, because early in my career, like data science started taking off in 2012, 2014. I'd gotten my master's, but at that time, a lot of the companies were requiring PhDs, because data science is like a really whole different beast. It's not like going to a code camp and learning like C++ or Java and you're all set. You need to learn all these variety of subjects. You need to learn math, you need to learn calculus, and they believe like only PhD people are capable of that. But starting in like 2014 with the revolution in big data, it kind of revolutionized the whole companies, because anyone could like make a startup, borrow some Hadoop clusters or Spark clusters, and basically have like whatever data they needed in order, for like maybe a startup idea. So initially, like there was a huge separation in data science and data engineering. Like if you were a data scientist, you were someone who had to show like you were competent with models, you were competent with mungling data and having a familiarity with the data. And if you were a data engineer, you had more software engineering experience. You knew algorithms, you knew data structures. But right now, probably in the last 2 or 3 years, they've increasingly converged it. So my recent interview with Moody's, actually, they required not only data science and data engineering experience, and a lot of the companies also were requiring that, because they want people who are very, very familiar with the models, because at some point when you deploy a model, then it's going to fail at some point, because there'll be some like novel data it's never seen before. And they want data scientists who are able, like on the spot, to diagnose what's wrong with it and fix it up. So they're requiring data scientists not only to know their specific field, but also to know, subjects like Kubernetes, because that's increasingly relevant. Ben, you were saying like that if something was missed, then there's hell to pay with the customer. So Kubernetes is like one solution that gets around that, because they modularize the whole production code. So they have like one part for the model, one part for user experience. So then as you input like a new update, then that section gets updated. And if there's something wrong, you can revert back to the previous mode, but you can update it without impacting the rest of the code. And they really, really make a big hay about productionalizing everything, because it seems like I don't know, companies silo everything through one person, because right now at Moody's, there is one person who's completely in charge of productionalizing aspects for their analytics code. So we can do all sorts of testing, but in the final end of schemes, he's responsible for deploying everything. And if something goes wrong, then there's definitely hell to pay with the customer. So there's like endless amounts of testing, endless amounts of QA. And then, of course, when you deploy, there's going to be like the odd data it's never seen before that is going to completely throw it off. So, yeah, data science is now becoming much, much more rigorous, because you have to be both an engineer and a scientist at the same time. So it kind of, I guess, gets intimidating and makes you feel like you have to be a mastermind at some point.
Yeah, I mean, I really see the convergence to follow on with what you're saying.
Yeah.
Between that traditional data science, and before we were called data scientists, we were called statisticians or analysis engineers or whatever. People dealing with algorithms and statistics and just doing large scale analytics or even small scale, merging that to data engineering techniques, but also that software engineering know-how as well. And there's very few people that have that trio of hats that they can all wear. And I call people like that ML engineers. I know there's people that use that term differently, but it's sort of the multi-role person. It's what anybody who starts out in the field eventually needs to become if they're going to be hired by a startup to do everything. Of like, hey, you need to not only figure out how to talk to the business, identify potential projects that you're going to do, but write the ETL to get that data, make sure that ETL actually works and is consistent and is highly available, and then build your model, come up with a solution, and push it to production, regardless of whatever serving layer. Yeah, Kubernetes is great with pod deployment. It greatly simplifies bandit algorithms and blue-green deployments. It's awesome. But even doing like batch serving and edge deployment, you have to get familiar with containerization. How do you actually package services in an environment? What if you need to interface with Chuck's world? Or you're like, hey, front-end developer, I have a container that I need to embed in your code. Here's how I do it. Can you please reference this service? That full stack data science aspect is becoming something that a lot of companies are requiring a single person to have all those hats. I don't think the industry is there yet right now. I think it's interesting that people are requiring that, but there's just not been enough time. Exactly as you said, Daniel. The AI winter came to the AI spring sometime in 2014. People lost faith in data science work for, I don't know, a decade or so. And then the previous winter that happened in the early 90s, where people were like, yeah, we don't really trust this stuff because we can't explain it. And now that hype has built to feverish levels now. So people are like, we need somebody who can do it all. But most companies that are looking for that person do not have the budget to afford that person. That person is going to command probably over $500,000 in just base compensation per year. And I mean, they've effectively earned that by learning all of that stuff over 15, 20 years of work. There's so few people that actually have that right now. The intention that for what we were talking about before with mentoring is slowly growing people into that role. That was the intention of me writing the book that is about to be published in ML engineering. It's like, how do you glue all this stuff together and not just focus on the minutia of, okay, here's our algorithms expert. They can't actually write code. They don't know anything about data engineering, but they're really good at models. That person can grow into learning enough generalists techniques of other fields in order to be a little bit more self-sufficient. So it's an interesting trend that I see.
Yeah, and I think, like you were mentioning before, it really helps that what niche you go into, because when I started ML, I was an engineer and I was hoping to do computer vision. Then I got into natural language processing after liking one of the projects I did at work, but I was sort of still ambling around until I'd worked in finance companies and I started really liking finance. But because machine learning, there's just so many subjects. And I think initially what turns people, like, there'll be people who want to be prospective data scientists and say like, oh, this is so cool, I'm going to revolutionize the world. And then they start seeing like machine learning, and like they go on, Stack Overflow and saying, you need to know statistics, you need to know optimization, you need to know calculus, you need to know data structures and algorithms. And then people's egos get like rapidly deflated and they give up on that. So I think it really helps when you find a very certain niche. Like it could be reinforcement learning to do self-driving cars. It could be time series analysis for Internet of Things devices. So if you get really, really focused on that specific thing, then you find out some subjects are more relevant than others. Like maybe for time series analysis, data structures are not as relevant, but you need to know a lot of statistics. If you're doing reinforcement learning, data structures and statistics may not be relevant, but you may need to know a lot of optimization in calculus. So I think it's really helpful that you need to know very early on in your career what you want to specialize in, because once you do, you figure out which subjects are more important and which are less. And then like once you get into it, then you start getting like a real knack for machine learning. You'll start getting like a real knack of, like you were saying before, how to clean data, how to process data, how to do post-analysis. So then like later on, if you are tasked with going on to other machine learning projects outside of your domain, or you want to switch for some reason, you already have like the insights on how to proceed specifically with you have like the machine learning mentality in order to go on to future projects. So I think by forcing yourself into a tunnel vision very, very early on, you don't get intimidated by all the other subjects and you have like a nice starting point.
Oh, of course. Yeah. And that was the intention in how I crafted in the book as well, and how I do mentoring with people is, if you're working on a computer vision problem, using deep learning, for instance, you're like, I've got all of these different pre-trained models and architectures that are out there, but I really need to do object detection. I'm going to use a mask-R CNN in order to do this, and I'm going to get this massive data set. My focus with mentoring on the ML engineering aspects are everybody needs to learn how to code, and that means create maintainable, abstracted code that you can strip comments out of, and any other data scientist can read that code without having to develop a migraine or just wonder.
I have to ask: is this the norm though? Is this not the norm that ML engineers can code?
ML engineers can code. ML engineers are usually doing production ML. Okay. Not many data scientists can code very well. It's just because people are not focused on that right now, because the industry, certain industries are not nascent. Mm-hmm. As Daniel was saying, finance is not nascent in statistical inference and ML. They've been doing it for decades. So you have people that come from those backgrounds that their code usually is pretty awesome and it works pretty well. But you have people coming straight out of school that get hired as a data scientist at a mid-level company. They've never done ML before. They just see this person with a brand new fancy degree that they got. And they're like, yep, you're a data scientist. Go figure it out. They have school does not teach you how to code. You need a mentor. You need somebody who's like watching you and saying, hey, I just did your code review. Here's the 847 things you just completely screwed up. Like refactor all this, because it may work right now, but you're never going to be able to update this. And ML code for most applications needs to be frequently updated, particularly supervised learning. There's a lot of changes you need to make over that life cycle of that solution, because drift happens all the time and you need to counteract that. So you're going back. And as our guest last week was saying, and he says this quite often, Laszlo, for every time that you write the code, it's being read 10 times at least. So the more legible your code is, the more abstracted it is, the simpler it is, the better it's going to be for the team. So I think ML, all data scientists need to learn that. They need to learn the techniques for writing good code that can stay the test of time, where that project is prepped for running in production for 5 years. Not, hey, we're going to release to prod, we're done. Hands in the air, pop the champagne bottles, and we succeeded. That's the start of your project, is when it goes to prod. And prepping for that. I think that's foundational. And then exactly as you said, Daniel, like focusing on one field or a family of fields that are related to what you're passionate about and what companies you want to work for that do that sort of thing. Yeah, that's key, because there's no way you're going to move from mastering image recognition with deep learning frameworks and then swap over to NLP and expect to be a master at that. That takes years to learn how to be good at that. And then you go from that to statistical inference on time series data sets. That's a completely different set of tools. It's a whole different knowledge base you need to gain. And then you move from that to, doing sort of traditional supervised learning techniques on certain domains. It's too much to learn in one career, in my opinion, to get really good at it. So yeah, I wholeheartedly agree. Specialize in a form of ML to be successful in a career, to craft that path, but also pulling in techniques that the software engineering community has been doing for decades, which is writing good code, testing, and that's unit testing and integration testing, making sure your code still does what you think it's going to do, monitoring, statistical attribution analysis, so you can prove to the business, this is the value of what I just built, and here's the evidence. And being able to do EDA, so analytics stuff. I think that's common to any field of ML, even if you're dealing with images. Like there's some amount of analysis that's involved there, and also data engineering techniques. You don't have to write full ETL pipelines from scratch. I mean, it's beneficial if you know how to actually push data to a Kafka queue, but most companies don't require data scientists to do that. But you should be able to interface with Kafka, drain that queue, and write it out somewhere to a data lake as a data scientist. That's a core, a key critical job skill, so that you don't have to rely on another team to do stuff.
Yeah, I want to back up to something that you said earlier, and then we can kind of move forward through some of the things that you pointed out, Ben. But you mentioned that your code should be simple and easy to read. And then you also mentioned that getting your code to production is the beginning of the journey, not the end of the journey. And the ideas that I want to tie together there are that essentially what you're implying is that this system is going to be maintained. And Daniel pointed out that, eventually you're going to hit some novel data that, gives you an unexpected result one way or the other, right? And that's part of that maintenance, right? And so if it's easy to read, it's easy to reason about what the code is doing, then you can maintain it and make it adjust for, or if you're doing a neural network or something else where you need it to be trained on stuff that looks like that novel data, you can adjust for that because it's simple to figure out where the problem is and what you need to do to fix it. And if you get code that is hard to figure out, hard to reason about, hard to find the stuff that you're working on, and trust me, I've worked on plenty of those.
Me too.
You spend a day or 2 or 10 just figuring out where the pieces are supposed to be. And it's a giant waste of time. People get frustrated because you're not getting them the solution in a timely manner. And at the end of the day, you're realizing that, this is where the problem is. The other thing is you also mentioned having a suite of tests, and that's the same thing, right? Is it that you can then write the test that pushes the new data in, or the triggers the scenario that you're getting unexpected results on. And then from there, you can start to adjust to see what you need to do to fix it, and experiment your way to a solution. And so I'm really digging this with the coding practices, because it makes a lot of sense to have all this stuff in place to begin with, because then you know where you're actually playing in this playground, so that you can be agile in the way that you approach it.
Yep, exactly. With Daniel's example with NLP, you get this new data set that comes in, this new set of records that come in that the model's never seen before. If you have a truly horrific horror show level code base where all of your feature processing that you're doing, and a lot of NLP has a lot of feature engineering associated with it. I mean, it's arguably most of what it is data manipulation and indexing and figuring out frequencies of terms and synonyms and stuff. So if your code is a horror show, which is, let's say, instead of being in a function or a set of dozens of functions. It's just a script. And you have this massive wall of text that could be thousands of lines long. And the code is so tightly coupled with orders of operations and dependencies mixed in there. If you didn't write the code, you have to now process mentally through every phase of that. You may have to put debug statements in to say, I need to see what the data looks like at this stage. So you might be opening up a notebook and stepping through the code in order to visualize what is going on here. That takes, for front-end code, that's hard enough as it is. Back-end engineering code, also very challenging. But for ML code, that can take, at a minimum days, at a maximum, potentially weeks. But what happens when that problem that you have coming in, that problem record of text, all of a sudden, when you do your reverse engineering of the code and troubleshooting through it, you realize that you can't insert that logic in that chain in order to fix it. That's when it becomes the problem of, hey, I actually can't refactor my way out of this or modify this. But if the code was abstracted in a testable manner and it's, chunks of it are done in a way that you're abstracting away this functionality, then you open yourself up to, hey, I know exactly where in the code it's this particular method in this class, or hey, it's this function that we have defined that's doing this one task. In order to fix this problem, I know exactly. I'm just going to add the logic in here or abstract this new transformation logic to a new method that I'm just going to call in part of this chain. So the code cleanliness is absolutely critical in ML for that maintainability consideration.
Yeah. I think it's interesting too that you talked about, hey, you want to specialize, but here are a handful of skills, techniques, tools that you need to understand.
Mm-hmm.
So when you're mentoring people, do you kind of push them toward that, or do you just kind of let them discover that they need them as a part of the process of them learning and then say, oh, you might want to look at one of these?
I'm the most annoying mentor on the planet. I take the Socratic method when I try to teach people. So I just ask them, okay, can you explain why you chose to do that? And then just continue to ask questions so that they realize that they might have had some assumptions about how something works or why something was important, or they didn't actually think it through. And I do that for two reasons. One, it makes them remember because they're defending their decisions or their thought process. So they'll remember that for the rest of their career, whatever topic we were talking about. And the second thing is it allows me to see another person's perspective. So mentoring is not a one-way street, in my opinion. I'm learning from them as well. It's not like I'm this God-level oracle of knowledge that I just know everything and tell them what to do. No. If I'm mentoring somebody, they're usually a highly intelligent human being who may not have the same background that I do, but the way that they think sometimes changes the way that I think about something. And that creative collaboration with the mentor-mentee relationship, it excites me every time I get the opportunity to do it.
And I think that approach sounds really good, because when you're dealing with machine learning, you're dealing with statistics in a large part. And stats are like a completely different thing from programming, because programming, you can just write linear code and you're done. But statistics, you can know all these formulas, but you still have to come out with like interesting experiments. You have to look at an experiment, think of all these possibilities, and you still have to like go back and forth for completing it. And a lot of experiments can get things wrong, like with polls. In like a statistics course, there's a famous example of how statistics got wrong, where they did the very first polling in the presidential campaign in 1936, and they predicted FDR was going to lose big, but FDR won big. And then because they based it on the polling that they did, and the polls said that they were going to vote for FDR's opponent. But when they looked at like the methodology, they were using it by calling up people. And that time in the 1930s, only people who were well off or rich had telephones. Poor people didn't have it at all. So they couldn't really think of it at all. So I think when you're dealing with statistics, the Socratic method really works well, because you're going down into the deep dive and wondering if this is like really relevant to the experiment or not.
Hey folks, if you love this podcast and would like to support the show, or If you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah. And what I tell my mentees, usually pretty early on when we're talking about models, is no matter how much data you're collecting about something that is reflecting the real world, you're getting less than 1% of the actual reason why that correlation shows up. The latent factors that influence, particularly when you're talking about human behavior, there's no way you know why something happens. You can kind of simulate it. That's a different form of ML, causality modeling. Good luck. That's a fun niche of ML, and I think it's super fascinating. There's not a lot of people that do it outside of certain industries, but traditional ML, deep learning, certainly, you're dealing with so many unknowns, and you're just trying to kind of find a good correlation that for some percentage of the time is accurate at predicting what is going to happen. So yeah, going through that process of asking the why, like why are you assuming this? Why are you doing this? Can you think about what it is that is going on here? It opens people's minds up to that statistical unknown of we don't have the whole picture, where the model is not omnipotent because we're not omnipotent and we cannot collect all the data. I mean, there's some use cases where you can, and I have seen people try to do supervised learning over a project that they are collecting basically the true answer within their data. And usually that's a conversation of, hey, have you tried an if-else statement? Because the answer's right there. Like, this always leads to this. So just do a case switch statement here.
Yeah, but case switch statement isn't as sexy.
We should not be going for sexy in ML. We should be going for, does it work? Does it work for a long period of time? And can I avoid PagerDuty notifications? That's the big goal. Like, make money for a company and avoid PagerDuty.
Nice.
I mean, that's how you write front-end code, right? You're writing it so it just doesn't break.
Yeah, I'm writing it. Yeah, basically so it doesn't break and so that the business people don't come and complain about it. So I guess the question is as people develop these models or develop these systems, I like the word systems better, right? Because it kind of encompasses the data systems and the machine learning systems and the delivering the outcomes systems, right? You kind of have these three different pieces. When people run into snags, right? When they run into I didn't expect this, or I'm getting results that don't work, or I'm getting results that are close here but not there, or things like that. I mean, how do you direct people back toward figuring out where the problem lies, whether it is with their data or is with their model or is with just understanding the result they're getting?
Oh, it's always the data. It's always the data. I mean, it can be the model. Like if you choose the wrong sort of algorithm for the use case that you're trying to do, let's say you have an unbounded problem and you're trying to predict some regressor that it's a continuous scale, and there might be a business requirement to say, hey, due to the bounds of physical reality, we cannot predict above or below these values for this particular use case. And if somebody's like, oh, I'm going to use a linear regression or generalized linear regression model, and because the training data is so bad, you get some new inference data that comes through and you predict a number that is, predicting revenue, for instance, and a prediction comes out that sales for this particular account in the next 2 weeks is going to be higher than the GDP of the EU. And you're like, okay, like that's a ridiculous prediction. It's bad. And this stuff does happen, but you can get away from that by switching an algorithm. You can just say, okay, I'm going to use a tree-based approach because there's bounds there that are based on your training data. So that stuff does happen, but usually you learn to avoid stuff like that by the time you have about a year experience as a data scientist. But the bad data causing issues, that's drift. Right? That's what we all deal with when we're talking about production ML. And it's going to happen. The only time that it won't happen is if you're monitoring some sort of static process. Like, hey, I know that this phenomenon that I'm measuring equipment tooling out in the field or something. I know that this thing can only generate data within these ranges of values. And if it goes outside of that, you know that there's some massive problem, like a data loss issue or something, or somebody pushed bad code in the pipeline that's coming in. So you can filter that out as part of your pipeline to say, hey, anything above this value, just standardize it down or just drop that row or something. But every other use case, particularly anything that is dealing with humans, all bets are off. So there's two different ways that you handle that with supervised learning and unsupervised learning is the two different methodologies of training or retraining. You can either do it passively, which that's just a cron schedule job. You're comparing prod against the new retrained version on the same holdout validation set. Keep whichever's better. It's the challenge or champion sort of deployment mode. The other way of handling it is active retraining. Active retraining is incredibly complex. These systems are not fun to build. I mean, the first time you build it, it's fun. It's like, oh, this is cool and new. The third time, fourth time that you build one of these, you do not enjoy it because it's a full stack of services that you have to do in order to do active retraining. So you're monitoring real-time performance of your model. You're doing sort of a late arriving data of true prediction versus whatever your stateful stored value of the prediction is. And you're calculating what your error is between real and actual. And then you have to maintain window aggregation states of that over time. So you have to smooth that data depending on the use case. You'd say, all right, over the last 4 days in hour increment blocks, if I have like a REST API service, what is the rate of success that I'm having for this data and my model that's in production? If I dip below a certain threshold that the business tells me is the accuracy threshold, then I need to asynchronously kick off a retraining run on the new data and do the same thing that you do with passive, which is comparing new versus the current production. And then you get a candidate new model that's going to now compete with the current production. So that you can handle that through multi-arm bandit logic, where these both are running in parallel. Kubernetes pods are amazing for this, by the way, just as Daniel mentioned. You deploy both of these and you start doing application load balancing routing. So you can do an online A/B test real quick that's basically saying, is this performing as well as production is currently? If so, start diverting more and more traffic to this new pod, this new REST API service. There's a lot of pieces that queue state management. Typically, you handle that in an in-memory database. So you need to spin up Redis. That Redis is probably going to have to be sharded if you have a lot of traffic volume. You need to now run statistical models on top of that as asynchronous processes that are triggered, saying, "Hey, every 5 minutes, run stats on this. Am I doing as well as prod? How is prod doing?" Yeah, so it gets really complex really fast, and usually you only see these active learning systems in the big boys, big companies that have a lot of money on the table and don't want to waste people's time with visually looking at this or running analytics on it. You just want an automated system to handle this.
I think to add one thing you were saying about drift that is coming in, I just wanted to say with machine learning systems in general, your model is only really good as the data you train with. And I think there's a lot of interesting parallels between machine learning models and human psychology, because if you think about it, machine learning models are in many ways how humans learn a lot of things. When you have a child, you're telling them this is a dog, this is a dog, this is a dog. And then eventually when they see a breed they never saw before, then they'll recognize it's a dog. But then sometimes once in a while, there'll be a certain breed that really, really does not look like a dog at all. And you have to tell them, oh no, that this is a dog. And I think there are really interesting implications, because a lot of people think that machine learning is true artificial intelligence, that it's going to predict everything and it's going to take over. And it's not, because, your data is only good as your labeling team is. It's only good as within the limits of your algorithm. And it's only good with the knowledge and comprehensibility of your domain space. So, for example, natural language processing engineers, they could be programming all these news articles, but if they had no idea about a black box event, the 2008 financial crisis, then that's still going to miss a lot of things. Like there could be some indications, but there's going to still be really no hint at anything at all that they would have picked up anything still like the 2008 financial crisis. And sure, now in retrospect, you can program all those news articles and all the stocks and be prepared for that. But there's probably going to be another black box event that is totally unaccounted for and is still going to be missed. So really, your only machine learning is still going to be like a human. I mean, a human is probably the most complex computer on Earth, but it still has its own biases and so on.
Yeah, 100%. Couldn't agree more. I mean, in the more recent black swan event that occurred, who predicted COVID was going to happen? I mean, there were people that were saying, hey, this is going to happen. Famously, Bill Gates was saying, we're not ready for this, but this is going to happen. Nobody's taking that data of experts in the field and philanthropic billionaires, their statements, and putting it into their price prediction model or price optimization model for their cereal on a grocery shelf. Nobody's doing that. So those latent factors, the data is out there, but you don't want to introduce seemingly useless or unrelated data into a model. And it's important to communicate that to a business. If you're a data scientist working in that, for a company, if they ever come back and say, hey, why didn't we predict, this thing happening? This AI was supposed to do this. And just have that conversation. Say, we're not including any data that we would have known, or we don't have the foresight to know that this was going to happen. And there's little mini black swan events that happen in industries all the time. A company is not doing so well, or let's say a company is doing super well. And then companies that interact with them and business to business transactions, everybody's happy, everything's going great. And then on a Friday afternoon, some really bad news comes out about the CEO. And now all of a sudden, these other companies don't want to do business with you anymore. A black swan event like that, you can't predict it. It's going to completely tank your sales. Bad things happen to the business. So I think it's critical to explain to the company, here's the limitations of what this is. Please stop looking at Hollywood films. We're not building Skynet here. We're never going to connect any algorithm to a gun, but it's also not omnipotent. It can't figure out everything. It can solve a problem provided we have the right data that has the right correlations to the target that we're doing, or meeting the business need that we're striving to solve.
Yeah, I would want to probably more consider machine learning as like a more efficient and hands-off way of doing coding. Because like when I was working at Bank of America, we were tasked with like updating their anti-money laundering system from a rules-based meaning that it's just programming code, to a machine learning model. And rules-based, they had like rules-based code for all these exceptions that go on, but eventually it gets like very, very clunky and you can't think of all possibilities, and you are doing like things post hoc, like there was some criminal who came up with this ingenious method, they caught it, and then they have to code that in, and it gets very dumb. So machine learning is basically like making it more efficient. So not only it takes care of those possibilities, but some future possibilities. And it may get some future possibilities. And if your model is explainable, then they can go in and say like, it's learning to recognize these type of scenarios, which we never thought possible. So that's like a very interesting thing from a psychology perspective, but it's still not going to pick up things, 100%. And it was like an interesting conversation I had a while back about self-driving cars with someone. And they said, when self-driving cars become much better, probably the driving rate is going to be 99%. There's going to be 1% chance or less that you're going to get into an accident. And that's actually much better than maybe the typical human, which is probably 10%. But still, there's going to be the odd accident here or there. But because people's expectations are so inflated, they think like, oh, ML is going to solve everything. But if a self-driving car, I don't know, sees a scenario like and gets into an accident, then everyone is going to freak out and say like, oh my God, the robots are taking over or they all failed. So everything is going to freak out in proportion to the expectations.
Stupid robots.
I mean, technically stupid humans that train the robots, but our world is flawed. The data we collect is flawed and our implementations are flawed. It's just how things happen. But I wanted to double down on what you said, Daniel, about, and that's something else that I talk to people about mentoring, about the heuristics-based logic that you saw at Bank of America. And I use examples like that to get people into understanding how ML project selection works. And the first thing that I personally use whenever I'm talking to a new customer who's talking about doing an ML project is I say either who's solving this right now with their own brain or their own processes, or can you actually write down logic on a piece of paper of how you would want this problem to be solved? And that's a good bellwether of saying, hey, is this even a feasible project? Do we have the data that we would need in order to make this decision? And the heuristics-based engines, I'm a fan of starting with those actually when initially tackling some sort of business problem. It can be something as simple as your prototype is in SQL. And it's just saying, when I see this condition, then do this. See what those predictions look like, even though it's incredibly simple, nothing sophisticated. But that's your baseline to say, okay, the ML solution that we're going to be building for real has got to be at least as good as this, or else there's no point in doing it. Or if the rules are so large, which I'm sure is exactly what you're seeing at Bank of America. I can't even imagine how big that heuristics code was. Probably thousands of lines of SQL or Python or whatever. But when it becomes unmaintainable, then ML that is just exactly as accurate or even a little less accurate than the heuristics based becomes more appealing because you can't keep adding to a heuristics engine. There's a point at which the human mind cannot rationally think about how to maintain that. And you can think about it with a decision tree. When you're firing in even a simple decision tree, ML, when you're doing five features and your conditional logic that model generates, you can look at it on a single screen. You can look at what those decisions are going to be based on how many nodes you have and how deep it is. It's not going to be that big. It's something you could just directly translate into logical code with ease. But what happens when you have 1,000 features in there and all of those 1,000 features are actually important to solve that problem? So when heuristic engines get to that size, that's basically what they're doing. You would be scrolling for minutes to get to the end of that and really understand it.
Yeah, well, you have to play the game too of, okay, which exception to which exception to which exception to the rule, right?
Yep.
I mean, depending on what you're looking at. I mean, hopefully it's simpler than that, right? Where you're looking at it and you're going, oh, okay, this falls under this rule, or maybe this falls under this exception to this rule. But it sounds like, you have a bunch of ifs, if this, unless this, if this, right? And so it's like, okay, under what circumstances, right? And
or you get to if this and this and this and this, else this and this and this
right.
and this, else this. Yeah, it gets crazy.
Yeah, I mean, it could be really well organized to the point where it's like, okay, this is kind of it's a basic decision tree, and we all understand kind of the flow to this, where it's just going to drop through. But even then, I mean, then you're getting into, okay, now I really deeply understand the rule set, and so I know which conditions are going to trigger this thing. And I don't know how you keep all that in your head if it's a complicated set of rules.
You don't. It just becomes so painful that you're like, hey, this is why ML was invented. Let's do ML.
I would add as an offside that the finance industry that I worked in with Bank of America, they're fundamentally very conservative. And even though the rules base was very, very clunky, they were still willing to go with it. It's just that their competition, like Goldman Sachs, was starting to use machine learning based solutions, and they were getting like much more accurate results. So that kind of like made them push the ball to adopt machine learning solutions. Like some companies, if they don't feel any competition. They're willing to go with like, their existing processes unless they're forced to by outside competition. I mean, for finance, it was a bit different because since 2008, they've been very, very sensitive. Like they had relied on the quants and then the quants spectacularly failed. So they kind of like went into the opposite realm and were extremely reluctant about adopting new technology because they were afraid of, some sort of repeat of 2008. But obviously machine learning based on the competition was getting like so much fabulous results. So even very conservative institutions have now been pushed in that direction.
That's super interesting too. All right. Well, I have another call in 15 minutes, so we kind of need to get to picks, but I find that last point that you made, Daniel, really interesting, just in the sense that they're getting fabulous results and we can push the industry forward in that way, right? Where everybody starts using a better mechanism, right? And then improving that better mechanism along the line to be more competitive. I mean, I love that. I think that's awesome. And it's also an opportunity if you're kind of a geek like I am, and I feel like you guys are, in the sense that you're looking at it and going, okay, what can I push? What can I learn? What can I experiment with, right? It opens up all those opportunities for folks like us. And so I think everybody benefits from that, including the technologists.
Yep.
All right. Well, let's go ahead and do picks. Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev. Ben, why don't you start us off with picks?
Ooh, I don't have a nerdy, geeky tech pick this week. I mean, I have been playing with our internal new releases at DataBricks with like the feature store, building a bunch of stuff out with that. And it's amazing. But my personal pick has been exploring HD plus music on Amazon Prime. And I just got a new high fidelity system, a nice Sony 7.2.2. The thing is awesome. So I've been really enjoying just sitting back, relaxing after writing some code for somebody and just decompressing, listening to some of my favorite stuff in ridiculously high bitrate audio.
Awesome. How about you, Daniel? You have some picks for us?
So, yeah, I've been reading some economics books, as part of getting more into the financial field. So one book I've been reading is called Debt, The First 5,000 Years by David Graeber. And when you read economics books, there's always sometimes a bit of a political bias. So this one is a bit of a left-wing bias, but I still found like very, very interesting insights. So we think of debt, like you're owing money to a person and, you have to pay them back with interest. But they talk about like debt, how it was perceived throughout history and with a lot of like anthropological studies. And it's, very, very fascinating because it shows that debt was actually around for a long time, even in so-called primitive societies. So like we think debt as a modern thing, like people go into debt in order to like for venture capital, but they point out it's always been there. It was just under more moral and altruistic ways of thinking. So like if you owed, I don't know, a service to Grog, like you owed 30 chickens to him, instead of like paying it with money, you might pay it with some sort of money, but you might also do it with like a given service because if he was your friend, you're always going to tie up like personal feelings into it. So I've been starting to get into that book, but it's kind of like really upended my concepts of how we think of debt in terms of moral concerns.
Mm-hmm. It's interesting too, because
not just the social impact of like having your friend, but the city I live in, if you go back, even 30, 40 years ago, it was a farming community. And what I found interesting about that is you look into some of these communities that are very heavily agricultural, what you'll find out is that this year so-and-so's field got worms, and next year the other so-and-so's field got whatever, right, and wiped out their crop. And so it is kind of this altruistic thing because everybody chips in to help out the Smiths over here, right? And then the next year everybody chips in to help out the Joneses over there, and everybody just kind of has the assumption that one of these years it's going to be me, right? And so you give people with the expectation that they'll help you out when it comes. And so I've seen kind of informal understandings of social structure there as well, which isn't specifically recorded as debt, but at the same time, there's kind of the social understanding that we'll all pay each other back.
It's like a community debt, a shared community debt.
Mm-hmm.
Yeah,
exactly. Yeah.
And then the flip side is then you get into the specific, hey, I gave you so much stuff to help you get whatever you were going for. And so, I have some expectation that you're going to give me similar value back one way or the other. Right.
Mm-hmm.
Which is more formalized debt.
Yeah. Because a lot of debt today, if it's college debt or mortgages, it's, very impersonal. It's like a balance sheet and there's like no personal feelings involved, but the author is trying to show that debt always has some sort of personal feelings no matter what.
Yeah. Interesting. I'm going to have to check that out. I've got a couple of picks. One of them's kind of a fun pick. I found a list of 50 different types of grilled cheese sandwiches, and they look amazing. And so it's just a variation. It's like, here's the basic grilled cheese sandwich, right? And then here are all these other kinds. And so it's got different kinds of things you can put in the sandwich or different things you can put on the outside of the sandwich. Or anyway, I'll find a link to that and put it in the chat for the show notes. I also have been listening to this book, and I'm actually going to go read it. It was recommended by a friend of mine. It's called The Prosperous Coach. And so if you're looking at doing some kind of formal, it's mostly how to find coaching clients if you're trying to build your business. And I didn't plan that with this, but anyway, I did realize as I was getting ready to do picks, I was like, what was that book I listened to? And it just walks you through how to really add value to people, and then how to add value to people to the point where they want to pay you to continue to add value to them. And there's a complete set of techniques and tools that you use to make sure that you're just knocking it out of the park for people as a coach. So if you're looking to do coaching, check that out. I'm probably going to be talking about that quite a bit more on the Dev Influencers podcast. That's devinfluencers.com/podcast. And I'm going to pick that. And then lastly, I have been playing with Kajabi, which is a course product hosting kind of platform. And they just barely added podcasting features to it, which is what kind of got my interest, because the same friend who recommended The Prosperous Coach also recommended this. And he's moving all of his podcasts to it. He's been podcasting for longer than I have been. And so far, I'm really impressed with it. devchat.tv might actually wind up being hosted there instead of on WordPress like we've been doing. And mostly what I'm looking at there is to alleviate some of the maintenance nightmare stuff. Some plugins don't work with others. You upgrade one plugin and then all of a sudden other stuff stops working. So then I have to go in and fiddle with it. Some of the plugins just don't work the way you want them to. Some of the themes don't play nice. Anyway, there are a lot of nice things that kind of come with Kajabi. And then the other end of it is you can set up a membership site or digital product sales on it. And it'd be nice to just maintain all that stuff in the same place, because I have the Dev Influencers Accelerator. I've got a book that I am in the process of having edited so that I can do kind of a full-on release and do an audio book for. I'm starting to pull together a JavaScript club, which is effectively going to be users group type things and stuff like that, and a forum and stuff like that. And I want to pull all that together and I can manage it all in one place. And so anyway, lots of nice features there. I'll put a link to Kajabi in there as well. If you're looking to do a podcast, this is probably going to wind up being the thing that I recommend to people just because it does so much. It also manages your email list. So I'll probably move my email list over there because I haven't actively maintained or done a ton in ConvertKit. So there's not a huge a huge downside to moving over to Kajabi there either for me. But yeah, it's just been really interesting to kind of try out this new platform and find that it eliminates about 6 services that I pay for right now and simplifies the podcast release stuff. So anyway, that's what I got. And I guess we'll just wrap up here. And until next time, folks, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.